How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we are going to be talking about virtualization and all the cool stuff that goes along with that. So we're going to talk about server virtualization, we're going to talk about containers, and then we're going to talk about VRFs, or virtual routing and forwarding tables. So there's a lot that goes into virtualization and how it works and things like that. So I want to take some time to try to help everybody understand how this works and stuff like that. I'm going to show you a little bit of virtualization that I have working in my home lab. Not 255.1.102. So the first thing that I want to show you before we go any further is basically the de facto standard for virtualization that you're more than likely going to see in a enterprise environment, and that is going to be VMware ESXi. And this is VMware ESXi. Bring this guy over here. We'll go ahead and log in to the server, and this happens to be this is a Cisco C240 M5 is the physical form factor, as you can see right here. There are two 22-core CPUs, so there are two sockets, so two CPUs, and there are 22 cores per socket, and I am rocking Xeon Gold 6152 at 2.1 gigahertz. So that's not too relevant per se for what you guys need to be aware of. It just happens to be a CPU type that Intel produces. The Xeon platform happens to be the server CPU platform that Intel produces. And this particular server has 384 gigs of RAM, and I've got about 90-ish gigahertz of compute, so CPU. Now, if we click on the Virtual Machines tab, I've got a bunch of different virtual machines running at the moment. This is my NSXT lab. I actually put the timeout on that so that I could focus on enterprise. So I'm actually going to, here in the very near future, once I have the enterprise series completely done and it's been published, so you guys can watch it on YouTube or on Patreon, I will rebuild this entire environment from scratch, and I'll walk you through, I think, 3.2, and then I'll do an upgrade to 4.0. But the reason why I'm showing you this is because this is the platform that server virtualization is built off of. So when we talk about virtualization, it is a way of taking the CPU, the RAM or memory, the storage, and the networking, and allowing multiple devices to take advantage of that. So when you are talking about typical virtualization, you're talking about a hypervisor. A hypervisor is going to allow for the virtualization of all the hardware resources that you can present to a virtual machine in a software context. So all of these virtual machines you see right here, DOM, Con, SAN, DC1, Tor, DC1, M04, etc., etc., these are all virtual machines. And each one of them has a guaranteed amount of resources. So, as you can see here, the server happens to have two CPUs and 8 gigs of RAM, and has a couple of network adapters attached to it, these two right here. So the resources that this server has, you can go through and you can put in minimums, you can put in maximums, you can put in reservations, things like that. I'm not trying to get into how does resource reservation work in VMware. That's a whole thing in itself. But what I am trying to help you understand is the cool thing about this is when you're digging into it, and for example, when you're looking at, go ahead and log back in here real quick. When you're looking at an environment, for example, once it loads, up here at the top, or down here, well, probably up here, these servers, server 84, server 85, could very well be this guy right here. Now, it's not, but it could be. Now, the reason why I say it that way is because in a traditional enterprise environment, most customers that I've worked with, if they weren't already mostly virtualized, they were pretty close to it. I won't say there's a capability of 100% virtualized. I'd say 95 to 98% virtualized. So there are going to be things that you can't virtualize. For example, there might be an application that's resources requirements are too much for virtualization to support. You might have a database that just can't be virtualized. Maybe you tried and it just doesn't work. So not everything can be virtualized. A lot of things can, but not everything. So when we talk about that is one of those things where you have to keep in the back of your mind. You're going to look at 95 to 98% virtualization in most environments. If they have a virtualization footprint and they're running VMware, they're in their 90 plus percent virtualization is probably where they're at. If not, they might be working towards that, and that might be part of your job. So, just some things to keep in the back of your mind when you're looking at how this stuff works. So that is essentially how that comes into play. Now this environment here, what I'm looking at is I've installed ESXi directly to the hard drive of this particular server. And when you do that, that's what they refer to as a type 1 hypervisor, which means you are bypassing everything and you are simply using ESXi to do all of the management and the virtualization of the computer or the server. You can do the exact same thing with Eve. This particular Eve installation is a type 1 deployment as well. I installed Eve directly to the hard drive. So this server right here is not a virtual machine running inside of this ESXi environment. I'm not doing a nested environment, especially for the amount of devices that I'm running. Now I used to try to do that. So if you watched any of my older content, probably a year or so ago, I decided to go the big Enterprise Lab 1. That was the first real large environment that I did where I installed Eve bare metal, and I've continued to do that. I get way better resource utilization doing that. Again, type 1 means you're installing the hypervisor directly on the server. So you're not installing, say, Microsoft Windows or Server 2012 or 2020 or 2019 or whatever the newest release of Windows Server is. You're not and then taking and installing what they call a Type 2 hypervisor, like VMware Workstation or VMware Fusion if you're on Mac, or VMware Player if you're doing just a single instance, where if you're doing a Type 2, you're running a base operating system, then you're running you install VMware Workstation, for example, on top of that Windows Server or Windows PC, and then on top of that, you're running all of your VMs inside of it. So it's nesting inside of nesting, and that I have only run into problems with. So that's basically what the difference is. So just to recap that real quickly, if you're running a Type 1 hypervisor, whether it is ESXi from VMware, whether it is Hyper-V from Microsoft, whether you're dealing with Zen from Citrix. Now, I don't know how much server virtualization Citrix actually does. The only experience I have with Citrix is going to be desktop virtualization through VDI, or using the they do a lot of application virtualization. So it's just one of those things that it's a possibility. So there's also a open source version. Proxmox does something similar to that. I don't have any experience with Proxmox, but that's just another platform that's out there. So when we talk about those things, those are Type 1 hypervisors. So you're using the hypervisor to manage the server resources. So there's that piece. Now, the next thing I want to talk to you guys about is going to be, we talked briefly about the virtual machine, and we can, let me click on host 3 here. Now this is ESXi that has been virtualized inside of ESXi. So it's a nested environment. So yes, you can install ESXi on top of ESXi, and it will, if you configure it correctly, you can run virtual machines on this ESXi host here, and then be able to interact with them. They'll be able to go reach the internet and all that other cool stuff. So that is possible as well. So again, you're doing software emulation. So you are taking the operating system of a server and you're installing it. In this particular case, it's ESXi. But for example, for DomCon here, we're taking Server 2019, the operating system. We're installing it as an ESXi virtual machine. And then if I wanted to, this guy is up and running. So I could go here to my remote desktop session, and I'm going to say yes, and it'll take it a second, but here is my ESXi environment. So if I was to, that's NSX, that's VMware NSX, that is, let me refresh that real quick. So this is vCenter. That might take a moment to load. But the point being here is I am able to launch all of this inside of a nested environment. And that's what makes it cool, right? It gives me a lot of flexibility. That's going to take a little longer than I'm willing to wait. So that's some of the cool stuff that you can do with that. Now, again, you are taking advantage of there are shared resources, yes. Shared resources are there. So the CPU can be shared, the memory can be shared, the storage can be shared, and the networking can be shared. So you're sharing basically everything. However, when you are doing that, you're not sharing 100, not every virtual machine has 100% access to every resource. You are giving a very small piece or very small amount of that 100% to each virtual machine. There is an upper limit to how much you can give too. So for example, I don't know if you noticed this before, but on this Windows server, for my, this is my management box, my jump box. If I look over here at host 3, I've got 8 CPUs and 20 gigs of RAM. Well, right now I'm using about 700 megahertz, about 4 gigs of RAM, about 60 gigs of storage. I have more than enough storage, but my upper limit here, the first thing that's going to run out for me is going to be CPU. So yes, there is a limit to that, and if I was to right click here and go to edit settings, and then expand the CPU, it's not able to be modified right now, but the reservation is none, which means I'm not putting a minimum required of allotment of reservation. I'm saying you have unlimited access to the CPU. As long as it's available to you, you have unlimited access to it. Shares, I'm giving it normal. I'm saying you don't have any more priority over the CPU than anybody else does. And then down here, the hardware virtualization, expose hardware assisted virtualization to guest OS, which allows me to run a nested environment. So if I don't do that, I won't be allowed to run virtual machines on top of this ESXi host that's right here. Now, if you're having a hard time correlating that, that's okay. I'm not expecting you to. But in a real world environment, you wouldn't be running a nested environment anyway. As a matter of fact, VMware won't support it if you are running a nested environment. So in production. So if you want to test some stuff out and create yourself a test environment, this is a great way to do it. Test out all the VMware features you want, and then you'd be able to replicate that in hardware and do all the things that you want. So I'll be showing you guys VMware NSXT at some point in the near future. I just wanted to knock out this Encore series first. So that's basically how that comes into play. The next thing that I want to talk to you guys about is going to be containers and how that comes into play. Now, containers in and of themselves are similar to a virtual machine, but with a lot less overhead. So essentially, they are a lightweight virtual machine, and I want to talk to you kind of briefly about what that looks like. So I don't really have a good example of what that's going to look like, but like a virtual machine, it's an isolated environment where applications run. So the application is going to contain all the dependencies that the application needs to run. So there are some considerations for them. So for example, they share the underlying OS, and do not include a guest OS. So you're going to have a scenario where you're going to have like you got this virtual machine right here. So let's this DomCon, right? He's got Windows Server 2019. Well, there are certain capabilities that he could deploy. So for example, I could turn on this server, I could turn the web server service on, and then I could point to 10.255.1.100, and then I'd be able to pull up a web server. Well, the reality of it is, on a container, you would still be able to deploy things like Apache or Nginx for your web server. So you'd still be able to pull up a web page. However, you wouldn't have the overhead burden of a operating system like you would with Windows Server or Linux, so on and so forth. So you do get a lot more flexibility in terms of the capability. And so that's one of those things where you got to keep in mind what the container's job is to do. So that's at the end of the day, that's what a container is a virtual machine without a guest operating system is the most basic breakdown for that. So that's the easy piece to understand. Now the other thing I want to talk to you guys about is going to be virtual switching, virtual networking, and now this will I'll kind of peel over into VRFs here in just a moment. But the virtual networking, and I want to talk to you guys about this because it is something that is definitely something worth you understanding. Now, I'm going to see if I can't go back over here to this guy. Oh, it finally did load. Okay, perfect. So let me go ahead and minimize that. Move this guy down. Close that out. So a lot of these servers are disconnected, and if I was to minimize this, because M01 should be there. Let's go back over here. Disconnected. Why is he disconnected? Summary. This might just be old. Ah, license expired. Okay. So that happens. So once the license expires, it's been more than 60 days. So that's how that works. So no big deal. No harm, no foul. Like I said, I'll have to rebuild this environment because it's been sitting here for so long. But that's just good practice for me. So if I come over here to the networking tab, I have these things known as a vSphere distributed switch or a vCenter distributed switch. And this is the vCenter wide version. So essentially the way that networking works in a virtual world is you have this concept of a virtual switch. Actually, it'd probably make more sense for me to do it from the host level than it would be for me here. Because then you'll actually have a virtual switches. Is it gonna let me show it to you the way that I want it to be switched? Okay, yeah, right here. This is what I want you guys to see. So there is no physical aspect to this, right? It's 100% logical, but conceptually it works the same way. Now, I'm not going to go into a ton of detail on this because the fact that it's a logical construct. It's no different than that of a VRF. But what will end up happening here, and actually it'll make more sense if I was to draw here and give you guys reference. Go over to white. Okay, so what I want you guys to understand is this. So right now we have this one NIC right here. We have VM NIC1. It's a gigabit NIC. So most of your VMware connectivity is going to be 10 gig or higher. So what ends up happening is you have this thing known as a port group. So the port group right here is going to get a name, whatever that name might be. In this case here, it's management. So for kicks and giggles, let's say that you created a port group named data. You created one called storage or SAN, so on and so forth. Well, what's going to end up happening is you create that port group and you map it to a particular vSwitch. So this is vSwitch 0. We'll do that for both. Both port groups are mapped to this. A port group in VMware is the equivalent to a VLAN in Cisco. The key point here is, or port group, actually a better example for this is a broadcast domain. A broadcast domain is equivalent to a VLAN. That's actually the better correlation. Now, the way that that works is when you are working through a scenario where you have to do some VMware networking. Let's say that the data network, you're supposed to give that VLAN 10, and your storage network, you're supposed to give that VLAN 20. Well, what you do is when you create your port group data, you tell it which VLAN it's supposed to use. Same thing with SAN. You map that to the particular vSwitch that you want it to be attached to, and then by doing that, it's going to get attached to a VMNIC. In this case here, it's going to be VMNIC 1. When you do that, what will end up happening is VMNIC 1 will be physically wired upstream to some physical device, some physical switch. So what will end up happening is you'll have your physical switch upstream, and what will end up happening is on this connection right here, this will be a trunk link. And as traffic comes out of the ESXi host upstream to the switch, it'll get tagged with this VLAN ID. This VLAN ID will be received on the interface, the trunk, and the switch will know which particular VLAN to place that traffic inside of. That's the most basic explanation I can give you when it comes to how virtual networking works. So when it comes to that, that's the key piece that you need to understand. Beyond that, are there other things for you to worry about? There are, but for right now, not that important. Now that I've covered that, let me go back over here to our topology. That same connection, right, that I was just talking about, that's this guy right here. So in this particular case, what would end up happening is if this guy here was ESXi, and I had, let's say I had 10 VLANs configured on this server, 10 port groups configured on this ESXi host, I'd have to make sure that E1/2 is configured as a trunk link to allow all that traffic to come up. Now, what about the access port? When would you ever create an access port? Well, let's pretend that this server right here was a Windows server. And this Windows server had there's no hypervisor. So there's really no virtual networking on the host itself that we need to be worried about. So therefore, if it's a Windows server, if it's a standalone server, meaning there is no virtualization on it, then you don't need to worry about that. You can configure this guy as an access port because literally it's just an endpoint connecting to a switch. So you're good to go. Now, if you're looking, if you're on ESXi, if you're looking at Hyper-V, if you're looking at Proxmox, I would assume Proxmox does it too, but I haven't looked into it. If you're doing any type of virtual networking at the host level where you're dealing with multiple VLANs, you got to make sure that you're attaching that particular host to a trunk so that the switch knows what to do with the traffic when it receives it. And that's essentially how that comes in. Now, I will tell you that there is a lot more detail that can be gone into this. I'm giving you a high level because of the case that I'm in. What I'm going to recommend you guys do is I'm going to recommend you guys go read the official certification guide for the Encore exam. It's a lengthy book, but if you go through the virtualization section, there's going to be a lot more covered than what I'm covering here. So I could go into more detail, but I don't want this video to be 2 hours long. So I could go into a lot more detail and all that stuff, but I really don't feel like going into that level of detail. For the simplicity factor is that it's if you look at the blueprint, again, it is fundamentals. So I've covered server virtualization, I've covered containers, and now I'm going to go a little bit on virtual networking because it has to do with server virtualization, and you might have a question on that. You might be working on your CCNA or your CCNP or whatever certification you might be trying to tackle, and then you circle back and you end up going through and you're working for an organization that happens to have a very large ESXi deployment. Well, you being a new network person or working your way up in the network team, maybe you're operations now, you're trying to work into engineering and being a network engineer. Well, if that's the case, great. Because what you'll learn is that your ESXi host can do networking, and now you'll know from the switch side what those particular interfaces need to be configured with. That's a win-win. So the last topic here is going to be VRFs, or a virtual routing and forwarding table. And if you don't know what a VRF is, That's okay, I'm about to tell you. So let me come down here. So up in the upper left hand corner, I'm going to draw this out like this. Actually, I got a cord in my way here, just a second. So from a layer 2 perspective, when you're dealing with virtualization, you deal with a VLAN. Okay? When you're dealing with layer 3, you deal with a VRF. Now, the difference between the two is they're identical. When you're talking layer 2, you talk about a VLAN. When you're talking about layer 3, you're talking about a VRF. What's the difference? Well, they're really the same thing. It just one handles layer 2 and one handles layer 3. A VRF is a routing table, is a user-created routing table. A VLAN is you have the default VLAN, VLAN 1, and any VLAN you go create is a user-created VLAN, and therefore it is user-created, which means you created it, you have to apply it where it needs to go. Same thing with the VRF. On a router, you have the default VRF, and the default VRF is going to be your global routing table, or your global RIB, routing information base. You're going to hear me use the term RIB and fib a lot when we get down into the weeds of how all this stuff works. So when we talk about that if you do a show IP route, you're going to get the default routing table. Now, what will end up happening is that the VRF is used to create new routing tables. Now, what's interesting about this thing is that they're locally significant. So what you can do, you can go take a router, draw a circle for very simplicity. You can create this router, or take this router, you can plug an interface into one of its ports, and what will end up happening is, if I take this interface right here, the whole physical interface, and I'm going to say VRF-A. If I say VRF-A on the router, I created a VRF. But the question is, did I put the interface into that VRF? And the answer is, at this point, no, I haven't. So what I would have to do is I'd have to go to the interface and I'd have to say IP VRF forwarding A. And by doing that command right here, IP VRF forwarding A, I'd be putting that interface, I'd be taking it out of the default VRF, out of the global RIB, and I'd be moving it over here to the VRF-A routing table. Now, when I do that, you run into the concept of VRF light. So, again, VRFs are locally significant to the device. How do I route from the global routing table into a VRF table, or from a VRF table into the global routing table? Well, that's can be interesting. So a simple way to do that would be a static route, and I'll talk more about that later when we get into VRF aware routing. But in most cases, what you're going to do, and I'm going to show you if you want to keep your routing to a single router, which is very, very common, is you would have to start leveraging VRF aware routing, where the idea is, and this we'll talk more about this when we get into DMVPN and FlexVPN and how that works. But the idea here is you want to provide differentiation between church and state. So the way I word it that way on purpose. So what I mean by that is this. In a DMVPN environment, because it's going to be a topic of discussion as we get further along, when you start doing overlay networking, whether it's DMVPN, whether it's VXLAN, EVPN, whether it's ACI, whether it is SD access, anything like the MPLS VPNs, whatever the case might be, you run into this concept of an overlay-underlay concept. The underlay is going to be how you get from point A to point B. So the simplest way to explain an underlay, a UL, is going to be, if I want to go from where I live here in Milwaukee and I want to get down to Chicago, for example, well, I can do that. The only thing is I would have to get on the interstate and I'd have to drive south until I hit Chicago. right? That means that I have to pay attention to the roads. I have to know which lanes to get into. I know which interchanges I have to hit in order to get to Chicago. Okay, fairly straightforward concept. Most people could follow along. The overlay, however, is going to be as if I went to the Milwaukee airport, I got on a plane, and I flew from Milwaukee to Chicago. So it's a plane. I can still see, from a physical perspective, I can look out my window and I can still see the ground, right? However, let's pretend like it's dark out and you close the window, or it's too very, very bright out and you close the window on you get the aisle, you get the window seat and you close the window, right? One way or the other, you're not gonna be able to see what's underneath you. All you know is that you got on a plane and the pilot came over and says, "Thank you for flying, whoever." Temperature, time, wind, all that garbage that sometimes you care about in your destination city is XYZ, right? I've done a lot of travel. I've traveled quite a bit in my career, so flying is part of the deal. So, and then you take off. You're in the air for a little while, and then you land. That is an overlay. You don't get to have to deal with any of the stuff in between point A and point B. And the reason why I say it that way is because when we get into things like DMVPN, your internet connectivity or your MPLS connectivity that's going to come into the router will be in a VRF, which means you won't have to see it in order for it to work. And we'll talk more about that when we get into those particular areas. But what will end up happening is you'll put your internet termination interface and your MPLS termination interface both into a VRF. They could be the same VRF or they could be a different VRF. The bottom line here is this. If I'm going to leverage a VRF in order to do a differentiation between church and state, conceptually meaning that I want to keep the internet away from my internal network. So you don't if you don't get my point or my analogy there, differentiation between church and state, you don't want your local government telling the church what it can and can't do, right? That's the idea behind that. So, and vice versa. The church really shouldn't have any influence on whatever the government's doing, right? They keep out of each other's way. Doesn't always work that way, but you get my point. So the idea here is you put your internet connectivity, your underlay transport is in a VRF, and your internal network traffic is in your global routing table. So the reason why you would do something like that is it gives you the ease of management. So if I was to do a show IP route, I would see all of my internal routes, but I'm not going to see any of the external routes, right? So this will make more sense when we get into hardcore routing and stuff like that, but for the most part, this is a basic explanation of how it comes into play. Now, one of the things that's interesting is, like I've mentioned so far, VRFs are locally significant to the device you're on. Same thing with VLANs. If you want to be able to if you wanted to take, for example, this switch, then this switch, then this switch, and you wanted to cable them together, and then have a PC here connected there, and then a PC here connected there, what do you have to do with these connections right there and on all these switches? We'd have to have that VLAN created on all these switches, and then all these interfaces would have to be configured as trunks, right? Well, the cool thing about VRFs is they work in the exact same way. So I'd have my router across the way, and then they connect up here, they connect up there, they all connect to each other. So I'd have to create the VRF here, here, and then here. And then normally speaking, what you would do is you would go to the interfaces of each one of these guys, and you would use what they refer to as an 802.1q subinterface. And you would use VRF Lite, and you would use .1q trunks to connect them together. So you would be able to utilize the same physical interface multiple times, but you would virtualize it in terms of 802.1q trunking. So you're going to hear about this more when we get into inter-VLAN routing, where we talk about the concept of a router on a stick. And not really applicable here for inter-VLAN communication, but conceptually it's the same thing. So you're going to be using router as a stick to be able to get your routers to be able to talk to each other. Now what will end up happening here, and I'm going to do my best to try to articulate this, is let's say you've got VRF red, and he'll be like that. Then maybe you have VRF green, and then you'll see traffic going back and forth like this. What about VRF sky blue? Well, you'll do sky blue, sky blue, sky blue, and sky blue. So each one of those colors, omitting the white one because that's your physical connectivity, your red, green, and blue lines would indicate different VRFs. So this would give you end-to-end connectivity, and each one of the routers would have to have the VRF created. It would have to be mapped to the interfaces appropriately. You'd have to do the .1Q, all that good stuff that goes along with that. I'm going to show you guys how to do that. Now, there is a major drawback to doing this. There is a major drawback. So I had a customer bring this up probably 5 years ago, something along those lines. They wanted to do something like this because they needed to do separation of different business units and things like that, and they wanted to do this. And I said, okay. I mean, it's doable, but it's a lot of burden to get it right. So they were like, okay, well, what do you mean? So I started to explain how you would configure it and how you would go about doing that. So what's interesting about it is when you do something like this, in order to get traffic into and out of the VRF, there needs to be an exit point at some point. And I said, you haven't shown me where the entrance point or the exit point is. I said, what about internet? What about shared services? What about things like DHCP, DNS? Like, are you planning on having dedicated servers per VRF? And they're like, oh, we didn't think about that. All they wanted to do is separate the traffic. And I go, okay, there's a cleaner way of doing this. And the cleaner way of doing this is to use MPLS VPNs. I was like, if you want to get a more easier to work with deployment, the easiest way to do that would be an MPLS VPN, a layer 3 VPN in this particular case. And this way here it removes the VRF Lite process because, again, you need to have the VRF created everywhere. You need to have the interfaces placed inside the VRF, configured appropriately. It can be kind of troublesome. Now I'm going to walk you through how to do that in an upcoming video and how to get that configured, and you're going to see what I mean. It's a lot of individual work. Yes, you can copy and paste to a certain extent, but there's still a lot of management overhead and burden to keep track of what's going on, where it's happening, that type of stuff. And yes, you can do VRFs with all the different IGPs and BGP. So when the customer brought this up, I told them it would make more sense for longevity purposes for you to just leverage MPLS VPNs and go that route. And eventually we scrapped the whole idea because they realized that there were easier ways to do it, and I was off the project at that point. Once I explained to them what the process was and stuff like that, they were, I was brought in in a pre-sales role to talk to them about what we could do, and we gave them a quote of how much it would cost, and I think we came in too high, but it is what it is. So that's just one of those cases where you need to be cognizant of what it is you're getting yourself into. So there's a fine line between riding the how do I want to say that? If you are looking for this can be burdensome, right? And the one thing that you never want to do from a consultation perspective, right? I'm going to talk a little bit about the real world and how to mindset and things like that. There are terms, and you're going to hear sometimes people say, well, it's job security. Well, that is true to a certain extent. But the last thing you ever want to do is you never want to come up with a design that is too complicated for the customer you're working with to support it on their own. Now, there are scenarios where they're going to come to you whether they want to or not, or you can be like, okay, this is the way that I would go about doing it, and maybe it's a smart idea, maybe it's not. You have to cross that bridge when you get there. But the bottom line is, if you are developing a design that is going to be more complicated than what the customer can support, maybe that's not the right design. And I've been there several times in my past where I've had customers that I've like, okay, this is what the end result is going to be, and they're like, okay, well, cool, we're cool with that as long as you're going to be there to help us support it. Like, sure, I can do that. So sometimes it works, sometimes it doesn't. I have had customers that go out and they have like a fixed bid project, will implement said solution into their environment, and then they'll circle back a very, very short period of time later, and they'll end up signing a time and materials project with us, and for the simplicity of they don't want to be bothered with maintaining that, so they'll just pay me to handle it. Okay, cool. You just send me an email whenever you need me to log in. I pop into your network, I make whatever changes I need to make, and then, I bill you accordingly. I bill you for the time that I needed to do the work. So we have situations like that do come up, and you need to handle them. What you don't want to do is make that your regular business or your regular mode of operation. Your goal as a consultant is to identify the problem, come up with a solution to that problem, be able to articulate it to the customer in easy to understand terms, because you never know their technical level. They may not be as strong as you from a networking perspective. Most customers are not, especially if you work in the partner world. Most customers are not going to be as their technical depth is not going to be quite as deep as yours. So being able to articulate to them what's going on, and then implementing the solution, and then having some follow-on documentation or whatever. Sometimes they might circle back and just don't have you do the work. I'd say over the past 7 or 8 years that I did professional services, I'd say 90+% of the time, the customer didn't need to come back to me to do more work. Because either A, I would talk them out of something overly complicated, or B, they would be technical enough to be able to handle it on their own once we got them stood up. So I have had customers that I've done. I don't like to toot my own horn, but I've done such a good job of helping them understand what it is that they need to do, that once we got through the initial project and we had deployed what they wanted to deploy, and then they wanted to come back and add more capabilities to it down the road, yes, I was there to, from a design perspective, I helped them understand what they needed to do and then where they needed to do it. And then so when it came to them doing it, they stood things up on their own because they understood what was there. I was like, all you're literally doing is you're replicating config from here to here, making a couple of adjustments there, whop, bam, boom, you're in good shape. Sometimes it was me doing a lot of the heavy lifting to get them to a point where it wouldn't require them to do as much down the road, and they'd be able to handle it on their own. So sometimes it's easy, sometimes it's not. So the main point here is to come up with a solution that is going to get the job done, but isn't going to be overly complicated for the customer. If it is overly complicated for the customer, you may have to modify your scenario, or be like, okay, well, this is what it is, and are you cool with this? Well, if they're not, then you might have to come up with something else. Most cases, it's like, okay, well, we would pitch them like, okay, this is what we've come up with. This is the only way to do this. So here's something else to put your mind at ease. We know you brought to us that you don't have the technical data or technical depth or whatever the case might be. Here's a time and materials project to bill against, and go about it that way. It puts their mind at ease. Maybe they have the budget, maybe they don't. You have to cross those bridges when you get there. So that essentially is where I wanted to kind of go into some depth on how all that type of stuff works, because it's important for you guys to understand that. So we will be going through all of this if anything didn't make 100% sense, that's okay. I wanted to explain it at a high level to give you guys kind of like a bird's eye view of what it is we're going to be digging into. Once we get into that level of detail in those particular areas, I will do a deeper dive and show you how to configure it and get all this stuff working. So we are going to do a single router and then a multi-router VRF Lite deployment. So we're doing, multiple routing protocols and all that type of stuff. I'm going to walk you through how all that type of stuff works, because it's definitely important for you guys to understand. So if you have any questions, comments, concerns, please leave a comment in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine people in the next video.